in three component system, there are three number of components and each components having interrelationship with each other. Okay, so considering like three components x, y and z, so there should be a relation between xy, yz and zx. These are three relations. Okay, these are the binary relations. Okay, these are the binary relations. So all components are interrelated to each other through binary relations. Now, okay, considering these all are eutectic systems. XY is eutectic with eutectic point 1. Okay, YZ is eutectic, eutectic point 2. ZX is also a eutectic point 3. Okay, so we can draw the phase diagram like this. X, Y. Okay, for XY, this is the E1. Okay, like this Y, Z. Okay, E2, Z, X. Okay, E3. No, these are the three eutectic points. Now we have to combine these three eutectics. Then we will get the ternary relationship. Okay. Now we have to combine these solidus lines. Okay, this is Y and Y. So we can combine this, and this is Z and Z. We can combine this, we can join this. Okay, and this is X and X. We can also join this. So like this, a diagram creates. We can create the diagram. Okay. So this is one eutectic. This is the second one, and this is the third one. Okay, and these are the eutectic points. We can extend the eutectic points who will join at one point, that is known as ternary eutectic. Ternary eutectic point. Okay, for eutectic. Okay, ternary eutectic point. So ternary eutectic point, or you can say cotectic point. And these expanded curves, okay, these extended curves of eutectic lines, eutectic points are called as cotectic curves. Cotectic curves. Okay. Now, in case of this diagram, the temperature is shown in this direction, upward direction, but we cannot analyze the crystallization behavior or melting behavior in this three-dimensional diagram. Okay, so we have to view take the view from the upward side. Okay, from the vertical side we will see, and how this diagram is looking, that will be plotted, and we can analyze the crystallizing or melting behavior. Okay, so when we see from the upper side, it can be seen like this. Okay, this is a triangle. Okay, this is a triangle, and all these curves will be shown as straight lines. Okay, but these are not actually straight lines. These are sloping downward to the cotectic point. No, the cotectic point. So the cotectic point is the thermal minimum. Okay, cotectic point is the thermal minimum. That means any melt that can exist is up to cotectic point. Okay, after that everything is solid. Okay, below cotectic point everything is solid. Like if this point actually is shown here, but actually it will remain somewhere here. Okay, near base. So this will be the thermal minimum. Okay, so you can see in the diagram. Okay, in this diagram, see. See, so this is one eutectic, this is another, and this is the other one. Okay, and these are all extension of eutectic points, and these are all are joined at point M, which is the thermal minimum. Okay, below that everything will be solid. Clear? So when you see this from the vertical side, okay, we can see it like this: the diopside, anorthite, and phosphide system. So in case of this one, we can see that this is the X, this is the Y, and this is the Z. The cotectic curve of XY, YZ, and ZX. These are meeting at this point. This is called as ternary eutectic or TE. This is E1, E2, E3. Okay, everyone understood? Move to a system that is diopside, albite, phosphide system, or phosphide diopside albite system, you can say. Okay, so this is a eutectic relationship. Okay, the eutectic system, ternary eutectic system. Okay, ternary eutectic system. So what happens is there is a relationship, eutectic relationship between phosphate and diopside and albite, and phosphate and albite, which is not purely eutectic. Okay, it is actually near to peritectic relationship, but not neither peritectic nor eutectic. Okay, but it is considered as eutectic because there is spinel phase between this, so we can omit this thing. Okay, we consider this as eutectic. If you want to know what the spinel phase works, how the spinel phase comes, that is not of importance actually. So you can follow Morse. Okay, Morse book. If anyone interested in knowing more. Okay, so phosphate diopside albite, uh, albite or sorry, anorthite, phosphate diopside anorthite. Okay, phosphate diopside anorthite. So these are all eutectic. Okay, so we have to mention the eutectic uh, compositions. So you know about diopside anorthite system. What is the eutectic composition? Anyone? Okay, so diopside 58, anorthite 42 at temperature 1274 degrees Celsius. Okay, like that, phosphorite and your diopside. This is also have a eutectic relationship. Anyone? Temperature and composition of phosphorite dioxide, eutectic. Hmm? Phosphorite 88, dioxide 12. Okay, at let me see the temperature, 1387 degrees Celsius. Okay, at 1387 degrees Celsius. So this is the eutectic composition of phosphorite dioxide system. Phosphorite 88, dioxide 12, 1387 degrees Celsius. Okay, so you can see here it is mentioned the spinel phase. Okay, spinel phase. This is the spinel phase actually positioned here, but you can, it is considered a eutectic. So this is the eutectic point of diopside anorthite, diopside phosphate, sorry, and this is the diopside anorthite, and this is the eutectic point of phosphate anorthite. We have extended the eutectic points, and They all have joined at M. This is the ternary eutectic. We'll see what is the composition of ternary eutectic and the temperature of ternary eutectic. Okay. So melt, starting from a melt which is enriched in phosphorite. Okay, consider this phosphorite like phosphorite 60 and dioxide 30, anorthite 10. Okay, this is an example only, don't write anything. Okay, first you understand what is going on in this diagram, after that you will write. Okay, so considering phosphorite 60, dioxide 30, anorthite 10, so you know that the first mineral to be crystallizing is the mineral with the highest composition, no? So phosphorite, it is plotted in the phosphorite system, phosphorite field. So this diagram can be divided into three fields. This is the phosphorite plus liquid field, this is the anorthite plus liquid field, and this is dioxide plus liquid field. Okay. Sorry. So three fields, there are three fields. So at any field you can take a composition. So it depends that the point it depends that the fast crystallizing mineral, which will be the fast crystallizing mineral. ओके, कौन सा फास्ट क्रिस्टलाइजिंग मिनरल है, ये कहाँ किसके ऊपर डिपेंड करेगा, कौन सा फील्ड में वो आता है, ठीक है, जिस फील्ड में वो आएगा वही फर्स्ट क्रिस्टलाइजिंग मिनरल होगा. ओके, कंसिडरिंग दिस इज अबव 1700 डिग्री सेल्सियस. ये सब थर्मल लाइंस है, ये सब थर्मल लाइंस है. थर्मल लाइंस क्या होता है, आइसोथर्मल लाइंस. यहाँ पर जब देखोगे तो इस डायग्राम में तो ये एक क्या है, कोटेक्टिक है ये. ओके, ये कोटेक्टिक है, ये कोटेक्टिक है. तो इनके बीच में सब थर्मल लाइंस आएंगे, ठीक है, आइसोथर्मल लाइंस. ये सब सेम टेम्परेचर को डिनोट करते हैं. ओके, ये सब सेम टेम्परेचर को डिनोट करते हैं, एक सेम टेम्परेचर, आइसोथर्मल. ओके, ये सब जो भी तुम लोग देख रहे हो इसमें, इस डायग्राम में जो भी देख रहे हो, ये वर्टिकली प्रोजेक्शन हुआ है, लेकिन एक्चुअली ये इंक्लाइंड है, स्लोपिंग टुवर्ड्स द पॉइंट एम. ओके, पॉइंट एम के तरफ सब लोग ऐसे स्लोप करके जा रहे हैं. everyone is sloping towards the M point. Okay, that should be clear. Okay, because of the temperature is decreasing. No. So above 17 degrees Celsius, phosphorite 60 is at above phosphorite 60, dioxide 30, and anorthite 10 is above 1700 degrees Celsius. So when it touches the 1700 degrees Celsius isotherm, then the first crystallizing mineral will be what? This is the point. Okay, this is the point. Above 17 degrees, when it was even above 1700 degrees Celsius, it was above the liquidus. So above the liquidus, it is liquid in nature. Okay. So the first crystallizing mineral will be phosphorite. No. So now with decreasing temperature, phosphorite is continuously crystallizing. Okay, phosphorite is continuously crystallizing. So the melt is getting enriched or depleted in phosphorite. Anyone? The melt is getting enriched or depleted in phosphorite. Depleted. Okay, so the melt is getting depleted in phosphorite. So in phase diagram, what we denote? We denote the melt composition. No. So when the crystallizing is going on, so the melt is continuously being depleted in phosphorite. So the melt composition will move away from phosphorite end. This is the phosphorite end. So the melt composition will move away towards what? So the melt composition will move away from phosphorite, and the melt is getting enriched in which component? Dioxide and anorthite. No, if phosphorite is being depleted, then dioxide and anorthite percentage will automatically increase. So dioxide anorthite is increasing. So the melt composition will move towards the dioxide anorthite end, move towards the dioxide anorthite end, and it will move in this direction. Okay. So now when it joins the dioxide phosphorite co-tectic curve, when it joins with the dioxide phosphorite co-tectic curve here at point B, what happens? Dioxide joins the crystallization process. Okay, so phosphorite is getting crystallized. Also, dioxide will join, and dioxide will also get crystallized at this point. Okay, so now that from this line, what happens is the melt composition moves away from dioxide phosphorite join. Why? Because the crystal is being enriched in phosphorite and dioxide, and the melt is getting depleted in phosphorite and dioxide, and melt is getting enriched in anorthite. So the melt composition will move towards the anorthite side. No. So now this will move towards the anorthite side, and it will ultimately reach at point M. Okay, point M, that is the ternary eutectic. So what was happening in your binary eutectic? In case of binary eutectic, okay, this is X and this is Y. So we'll take a composition X 80, Y 20. So at this point, X will be started crystallizing. Okay, X will start crystallizing. Then, sorry, depleted. Okay, so X will start crystallizing, and it will continuously crystallize X crystals. No, X crystals at point E. What was happening? Anyone? So here X and Y will crystallize simultaneously. Like that, in case of phosphate and dioxide system, dioxide anorthite phosphate system, at this point, the every remaining single drop of liquid will crystallize here. That is phosphate plus dioxide plus anorthite. Everything will be crystallized here. Okay, at this point. No, okay. So the crystallization will ceased here. Okay, खत्म हो जाएगा यहाँ पर क्रिस्टलाइजेशन. सबको क्रिस्टलाइजेशन पाथ समझ में आया या किसी को कुछ डाउट है बोलो. We'll go to the phase rule. So above this system, when only melt was there, so let me draw the diagram. Okay, this is phosphorite, anorthite, dioxide. So this is the point A. Point A, we have I have taken phosphorate 60, dioxide 30, anorthite 40, anorthite 10. So above 1700 Celsius, 1700 degrees Celsius, there was only melt present. No, there was only melt present. So phase is 1. So calculate the degree of freedom above this system. Okay, when crystallization has not started, calculate. The degree of freedom will be 3, like P plus F is equal to C plus 1. Phase is your 1. C is 3, 3 component system plus 1. So 1 cancel, F is equal to 3. Degree of freedom is equal to 3. Anyone can name these 3? What are these 3 things? What are these 3 degree of freedoms? What is degree of freedom? First you say what is degree of freedom, then define these 3 things. Okay. So the degree of freedom is 3 at this area. Okay. So we'll go to the next phase. The phosphorite will go and join here. Okay, and from here dioxide will join the crystallization process. Okay, no, sorry. Now we have calculated for melt, na? Okay, so now at 1700 degrees Celsius, consider 17 degrees Celsius, the first crystal of phosphorite is crystallized. Okay, now the phase becomes what? Now the phase becomes 2. Na? Phase is 2. What are these phases? One is melt and another is phosphorite solid. Okay, one is melt, the another is phosphorite solid. Now calculate the degree of freedom for this point. Freedom will be 2, that is P plus F is equal to C plus 1. This is 2. Freedom component is 3 plus 1, so F is equal to 2. Anyone can define this 2? One is always temperature. One is always temperature. Temperature is variable. Okay. Now the another one. Here, so at this point, at this when phosphorite crystallizes, okay, when phosphorite crystallizes, so the degree of freedom will be 2, that is temperature, and x of dioxide or x of anorthite, any one. Now when this crystallization joins dioxide, okay, when crystallization process is joined by dioxide, when phosphorite and dioxide both crystallize, then this will be the path. Okay, now there are phases, 3 phases, that is one is melt phase, another is dioxide, another is phosphorite. 3 phases. Now the degree of freedom is equal to 1. Degree of freedom is 1. Okay, so what will be this degree of freedom? Only temperature. Only temperature, because we are getting x of dioxide and x of phosphorite, so the x of anorthite is already being defined. ओके, एक्स ऑफ डाइऑक्साइड हम लोग को मिल रहा है, एक्स ऑफ फॉस्फराइट हमको मिल रहा है, तो ऑटोमेटिकली मेल्ट में कितना अनॉर्थाइड रह रहा है हमको मिल जा रहा है. ठीक है, तो ये मिलके 100 होगा हमेशा, तो ऑटोमेटिकली मिल जाएगा हमको. इसका कंपोजिशन मिल रहा है, इसका कंपोजिशन मिल रहा है, तो नाउ ओनली इफ विल प्लेस द टेम्परेचर एनीवेयर. ओके, मैं बोलूंगा कि इस जगह के टेम्परेचर ये है, तो तुमको पता है कि भाई यहाँ पर एक फॉस्फेट कितना निकला है और डाइऑक्साइड कितना निकला है. ओके, so you can define the remaining component. Okay, only temperature is variable here. Now when you reach this point, there are 3 phases or 4 phases. Anyone? At ternary eutectic, how much number of phases are there at ternary eutectic? How many numbers of phases? So at ternary eutectic there are 4 phases. Very good. There are 4 phases. That is, phases equal to dioxide plus anorthite plus phosphorite plus melt. So the degree of freedom is equal to 0. That means what? This eutectic, ternary eutectic is always constant. Is always constant. It will not vary. Okay, until and unless the pressure varies. Okay, until and unless the pressure varies. We have calculating at constant pressure. At constant pressure. Okay, until and unless the pressure varies, the ternary eutectic is defined at a particular point. Okay, so what is this ternary eutectic? This is at like dioxide 50 or something. Let me check. Okay, so this one, So this is the ternary eutectic of what? Diopside phosphorite anorthite system. Ternary eutectic. Okay, phosphorite 7, anorthite 43, diopside 50 at 1270 degrees centigrade. So this is the ternary eutectic of diopside phosphorite anorthite. Everyone clear? किसी को कुछ डाउट है तो बोलो. Another thing. So when in this diagram, okay, if we want to know the instantaneous solid composition, okay, ISC, that is what is the crystal now is being crystallized, then we have to just plot a tangent. Okay, we have to plot a tangent here. Okay, we have to plot a tangent here. This is not a tangent, actually this one is curve like this. Okay ना, ऐसा कर्व है ये वाला. तो यहाँ पर अगर टेंजेंट प्लॉट करते हैं हम लोग, 3 डायमेंशनल में होता है वो, ठीक है, हम 2 डायमेंशनल में नहीं कर सकते, नहीं दिखा सकते यहाँ पर. तो अगर टेंजेंट प्लॉट करेंगे, ये जहां पर आएगा इस जगह आके इसको इंटरसेक्ट करेगा, उसका कंपोजिशन जो होगा, लाइक दिस इज इन डाइऑक्साइड 90 phosphorite 10. Okay, so at this point B, this is the tangent. Okay, this is the tangent. So at this point B, diopside 90 and phosphorite 10 is being crystallizing. Clear everyone? Tangent. Okay. For ISC, instantaneous solid composition, at that point, what is the composition of the solid that is being crystallizing? Okay. If we want to know the TSC, total solid composition, okay, total solid composition, then what we have to do, we have to take the point here. I want to know the TSC, so point and the original point we have to join this and extend towards the boundary. Okay, this is like this will be your phosphorite 60, diopside 40. So this is the TSC, total solid composition. Total solid composition means till this point what is the composition of the solid that are crystallized. Okay, everyone clear how to know the ISC and TSC? For ISC you have to draw a tangent. For TSC you have to join the point to the original point and extend towards the boundary. Okay, this is the ISC and TSC. Everyone clear? We are moving to the equilibrium melting behavior. Okay, now we are going back to the binary system, same binary system. Okay, dioxide and anorthite, dioxide and anorthite. So what happens when we are starting a dioxide plus anorthite crystal? When we raise the temperature, what happens at 1274 degrees Celsius? Anyone? So at eutectic point, melting will start. Dioxide and anorthite will produce melt of eutectic composition, and isothermal melting will go on until and unless one phase is completely melted. Okay, तो completely melt जब हो जाएगा यहाँ पर, तो ये univariant point है ना, eutectic point. This is univariant point. So if it is univariant point, it will go. Okay, so dioxide and anorthite will simultaneously melt. Ternary eutectic point, this is univariant point. So the melting cannot नहीं जा सकता ना छोड़ के पॉइंट, जब तक कि वेरिएंस 1 नहीं हो जाता. सो व्हेन अनॉर्थाइट मेल्ट्स, अनॉर्थाइट जब पूरा मेल्ट हो गया, यहाँ पर क्या होता है, यहाँ पर डाइऑक्साइड क्रिस्टल है प्लस अनॉर्थाइट क्रिस्टल है प्लस मेल्ट है, तो दिस इज यूनिवेरिएंट. सो नाउ अनॉर्थाइट पूरा मेल्ट हो गया, कंसीडरिंग डिपेंडिंग ऑन द कंपोजिशन अनॉर्थाइट पूरा मेल्ट हो गया. सो अनॉर्थाइट इज नाउ with the melt. So now dioxide plus melt are two phases. So the this melting can leave this point, because now the variance is 1. Now the degree of freedom is 1. So this melting can leave this point, and it will leave depending on the composition. Anorthite is being completely melted, so it will go to the diopside side. So it will follow the curve and go to the diopside side. Okay, so this is the thing. Everyone know? याद आया कुछ या नहीं आया? Okay, like this, the same thing will go on. Okay, so same thing will go on, and like this, like the crystallizing behavior, it is just the reverse of the crystallizing behavior, no? So when we start melting a solid composed of phosphorite 60, the same I am taking the same composition, phosphorite 60, diopside 30, anorthite 10, then the first melt will be produced at what degree and what composition? Tell me. So the first melt will be diopside 50, anorthite 43, phosphorate 7 at 1270 degrees Celsius. Okay. Now this point is univariant. So this melting will continue, go on, okay, until and unless one phase is completely consumed. So in this case, phosphorate 7 will be consumed. Anyone? Yes or no? No, this is the eutectic composition. Okay. So the solid composition is phosphate 60, diopside 30, and anorthite 10. Na? So anorthite will be consumed first. No, this is the eutectic composition. Why will be phosphate 7 will be consumed first? Okay. So anorthite 10 will be consumed first. Then the degree of freedom, the degree of freedom will be 1, and it will leave the curve, and follow this curve, follow this path. Okay. Now diopside and phosphorite is continuously being melted. Okay. Now at this point, the diopside will be consumed completely. Okay, diopside will be consumed completely. Then it will again leave this coat-active curve. Again leave this coat-active curve and follow this line. And now only phosphorite is continuously being melted. At this point, complete melting occurs. Okay. जैसे गया था वैसे रिटर्न आ गया. सिंपल. बस इतना याद रखना है कि फर्स्ट मेल्ट जो प्रोड्यूस होगा वो ये वाला कंपोजिशन का प्रोड्यूस होगा, रिगार्डलेस ऑफ द कंपोजिशन ऑफ द सॉलिड. ठीक है, इरेस्पेक्टिव ऑफ द कंपोजिशन ऑफ द सॉलिड, फर्स्ट मेल्ट हमेशा टर्नरी यूटेक्टिक कंपोजिशन का फॉर्मेशन होगा. यही चीज है. ठीक है. इक्विलिब्रियम मेल्टिंग सबको समझ में आया या फिर किसी का डाउट है? बोलो. Fractional crystallization. Okay, fractional crystallization. I'm moving to fractional crystallization. So in case of fractional crystallization, what happens? The amount of crystal that are formed are continuously fractionated from the system. Okay. So what happens now? Here phosphate is formed. First phosphate formed from the melt. Okay, then phosphate is fractionated continuously going out from the system. At this point, the amount of phosphate is crystal. Phosphate crystal is 0 ना. phosphate जो भी फॉर्म हो रहा है बाहर निकल रहा है, जो भी फॉर्म हो रहा है बाहर निकल रहा है. और इस पॉइंट में क्या होगा? डाइऑक्साइड फॉस्फेट को ज्वाइन करेगा, फॉस्फेट प्लस डाइऑक्साइड ज्वाइन करेगा. ठीक है, वहां भी क्या हो रहा है? जो भी फॉस्फेट डाइऑक्साइड क्रिस्टलाइज हुआ वो भी कंटिन्यूअसली बाहर जा रहा है. ओके, it is being continuously fractionated. Then at when it reaches this point, what happens? There is no crystal at there. Okay, there is no crystal, only melt is there because all the crystals are fractionated. Okay, so what will happen at this point? At this point all the remaining liquid will crystallize ना. तो all the remaining liquid कौन सा कंपोजिशन में क्रिस्टलाइज करेंगे? टर्नरी यूटेक्टिक कंपोजिशन में, दैट इज ऑफ डाइऑक्साइड 50, अनोर्थाइट 43, फॉस्फेट 7. बाकी कुछ क्रिस्टल नहीं रहेगा. इक्विलिब्रियम क्रिस्टलाइजेशन में जो क्रिस्टल फॉर्म हो रहे थे वो सिस्टम में रह रहे थे, ठीक है, इसीलिए उनका टेम्परेचर उनको अफेक्ट कर रहा था और वो पाथ फॉलो कर रहे थे, जा रहे थे, वहां पर पहुंच रहे थे। जब क्रिस्टलाइजेशन एंड हो रहा था तो सब क्रिस्टल एक साथ थे, तो उनका कंपोजिशन जो था, पहले वाला जो कंपोजिशन था जहां से शुरू किए थे वही कंपोजिशन मिला हम लोगों को। ओके, जो ओरिजिनल बल्क कंपोजिशन था वो फाइनल सॉलिड कंपोजिशन भी, टोटल सॉलिड कंपोजिशन भी वही हुआ। बट इन केस ऑफ फ्रैक्शनल क्रिस्टलाइजेशन व्हाट हैपेंस, all the previously formed crystals are fractionated out. So at last when we reach the ternary eutectic point, so only eutectic composition of melt is there, so we'll get the solid of composition what, of ternary eutectic. So in case of fractional crystallization, so in case of fractional crystallization, the final solid product is of ternary eutectic composition. Okay, that is dioxide 50, anorthite 47, sorry 43, and phosphorite 7 in case of fractional crystallization. Okay, ठीक है, सबको समझ में आया या फिर किसका डाउट है? तो fractional melting part. So in case of fractional melting, what happens? The amount of melt produced is continuously being fractionated from the system. फ्रैक्शनल क्रिस्टलाइजेशन में क्या हो रहा था, जो भी क्रिस्टल बन रहा था तो उसको निकाल देते थे हम लोग। फ्रैक्शनल मेल्टिंग में क्या करेंगे, जो भी मेल्ट बनेगा उसको बाहर निकाल देंगे, ठीक है। ओके, सो द फास्ट मेल्ट प्रोड्यूस्ड विल बी व्हाट, irrespective of composition, the fast melt produced will be टर्नरी यूटेक्टिक कंपोजिशन नहीं, जो हुआ तुम्हारा फॉस्फराइड 7, अनोथाइड 43 एंड डाइऑक्साइड 50. Okay, irrespective of composition, the first melt produced will be this, and the melting will, isothermal melting will go on until and unless one phase is completely consumed. So I am taking the initial solid as the same. Okay, phosphate 60, dioxide 30, अनोथाइड 10 को ही मैं इनिशियल सॉलिड के हिसाब से ले रहा हूं, इसको ही मैंने मेल्ट किया करना स्टार्ट किया। So the fast melt produced will be of this composition, and the melting will continue until and unless one phase is completely consumed. So in case of this, anorthite 10 will be completely consumed and the melt is continuously being fractionated. जो भी मेल्ट बन रहा है वो कंटिन्यूसली बाहर निकल रहा है, ठीक है, कंटिन्यूसली निकल जा रहा है। तो अभी क्या हुआ, when anorthite is completely consumed, then only it will move from this point, then only it will move from the point. So when anorthite is completely consumed, then what happened, anorthite is completely out of the system. Okay, if anorthite is completely out of the system, is this system can be called as ternary? The system can be called as ternary, yes or no? No, because anorthite is completely out of the system. So now only phosphate and dioxide is there, na? Anorthite is being fractionated continuously, and at the end of this melting, anorthite melting, so anorthite is completely out of the system. Now the system is completely what, binary. Okay, binary. So from this point, melting will directly shift from this to this point, and this is the binary line, na, phosphate and dioxide, where anorthite is 0, na. So melt will completely shift to this point. Okay, this is called as the temperature hiatus. Temperature hiatus. okay, or also called as melting gap. मेल्टिंग गैप नहीं, इतना समझ में आया सबको या फिर किसी को डाउट है? बोलो। So now that phosphate and dioxide remained, so this is the fractional melting system. Okay, तो फ्रैक्शनल मेल्टिंग सिस्टम में क्या हो रहा है, जो भी मेल्ट प्रोड्यूस हो रहा है वो बाहर निकल रहा है। ठीक है, तो इस पॉइंट, दिस पॉइंट इज व्हाट, दिस पॉइंट इज द यूटेक्टिक पॉइंट ऑफ डाइऑक्साइड एंड फॉस्फेट। सो यहाँ पर भी मेल्टिंग होगा वैसे ही। वैसे ही कैसे मेल्टिंग होगा, जो मेल्ट प्रोड्यूस होगा फर्स्ट, वो कौन सा कंपोजिशन का होगा? एनीवन? At this point, the first melt will be dioxide 88, phosphate 12. Okay, phosphate 12. थोड़ा उल्टा बोल दिया श्रेयसी। ठीक है, फर्स्ट डाइऑक्साइड 88, फॉस्फेट 12। ओके, डाइऑक्साइड 12 नहीं, इस तरफ से फॉस्फेट यहाँ 100 है, इस तरफ से 0 होता है, 0 तरफ आता है। डाइऑक्साइड यहाँ पर 100 है, इस तरफ से 0 होता है। ठीक है, तो डाइऑक्साइड 88, फॉस्फेट 12। Okay, no worries. So dioxide 88, phosphate 12. So at 1387 डिग्री सेल्सियस, तो यहाँ पर मेल्ट प्रोड्यूस होगा, और जो भी मेल्ट प्रोड्यूस हो रहा है वो बाहर जा रहा है। ठीक है, बाहर जा रहा है, इट इज कंटिन्यूअसली गोइंग आउट फ्रॉम द सिस्टम। ओके, नाउ दैट व्हाट विल हैपन, यहाँ पर क्या है, डाइऑक्साइड 30 है, ओके, एंड फॉस्फेट 60 है। सो डाइऑक्साइड 30 विल बी फर्स्ट कंज्यूम्ड। नहीं, तो डाइऑक्साइड 30 कंज्यूम हो जाएगा, तभी वेरिएंस बढ़ेगा, क्योंकि ये इनवेरिएंट से फिर से इनवेरिएंट पॉइंट तक ही चला आया, क्योंकि एक जो अनऑथराइज्ड 10 था वो बाहर निकल गया। नहीं, तो नाउ क्या होगा, डाइऑक्साइड जब कंज्यूम हो जाएगा तो वो क्या होगा, पूरा बाहर निकल गया। अब डाइऑक्साइड भी बाहर निकल गया सिस्टम से, अनऑथराइज्ड भी बाहर निकल गया। अब सिस्टम क्या रहा, अब सिंपली सिस्टम एक यूनिक कंपोनेंट सिस्टम रहा। तो जो यूनिक कंपोनेंट सिस्टम जब रहा, तो यहाँ से क्या होगा, यहाँ से मेल्टिंग सीधा शिफ्ट हो जाएगा फॉस्फेट 100 तक, क्योंकि अभी सिस्टम में सिर्फ फॉस्फेट ही है। डाइऑक्साइड तो मेल्ट करके बाहर निकल गया, अभी सिस्टम में सिर्फ फॉस्फेट है। तो फॉस्फेट जितना ही मेल्ट करता है 1892 डिग्री सेंटीग्रेड, तो उतना में मेल्टिंग खत्म होगा। ऑन दिस इज ऑल्सो ए मेल्टिंग गैप, और दिस इज ऑल्सो कॉल्ड एज टेम्परेचर हाइएटस। ओके, टेम्परेचर हाइएटस। तो दो मेल्टिंग गैप और दो टेम्परेचर हाइएटस आएंगे इसमें। सो द क्रिस्टलाइजेशन विल एंड एट फॉस्फेट 100, that is 1892 degrees Celsius. So in case of, you can write there, in case of in case of fractional melting, the melting will end at the at the at sorry, at one of the components corner, depending upon which component has the highest composition. Okay, हाईएस्ट कंपोजिशन। तो जिसका भी कंपोजिशन सबसे ज्यादा होगा, जिसका भी कंपोजिशन सबसे ज्यादा होगा, फ्रैक्शन मोल फ्रैक्शन ज्यादा होगा, वहां पे जाके क्रिस्टलाइजेशन सॉरी मेल्टिंग एंड होगा। ठीक है, इरेस्पेक्टिव ऑफ इरेस्पेक्टिव नहीं, रेस्पेक्टिव हो गया, ये मेल्टिंग के ऊपर, कंपोजिशन के ऊपर डिपेंड करेगा, इनिशियल सॉलिड कंपोजिशन के ऊपर। ठीक है, एनीवन साइड फॉस्फेट एंड सिलिका सिस्टम। ओके, dioxide, phosphate and silica system. You already know that dioxide and phosphate has an eutectic relationship, na? Eutectic relationship, dioxide 88, phosphate 12 at 1387 degrees centigrade. Okay, like that. Phosphate and silica, you already know what is the phosphate silica system. So it is the peritectic system, that is with reaction point, na? Peritectic system. So here it is the N-statite, and this is the reaction point. At this point, phosphorite reacts with silica and forms N-statite. Now, olivine reacts with silica. Olivine reacts with silica and forms pyroxene. That is Mg2SiO4 reacts with SiO2 and gives MgSiO3. Okay, 2 MgSiO3. This is the N-statite, or here it is called as proto-N-statite. Okay, so this is the peritectic system. Now about the diopside and silica system. Na? Diopside and silica. This is also a eutectic system with eutectic composition diopside 84, silica 16. Okay, diopside 84, silica 16 at temperature. Okay, let me check the temperature actually. 1371 degrees centigrade. Okay, so diopside, your diopside 84, silica 16 at 1371 degrees centigrade. Clear? So all the three systems are defined. ना कुछ रह गया क्या? डाइऑक्साइड सिलिका यूटेक्टिक, डाइऑक्साइड फॉस्फोराइट यूटेक्टिक, दिस इज द डाइऑक्साइड फॉस्फोराइट, and this is 1371 degrees centigrade. This is the diopside silica, and this is the phosphorate silica. Phosphorate silica is peritectic. So this system can be called as ternary peritectic system. Okay, ternary peritectic system. Peritectic system. Okay, this system can be called as ternary peritectic system. So we can plot the diagram. Wait 1 second. Okay, so this is the triangle. Here is your phosphorite, here is your silica, and here is your diopside. So phosphorite diopside is what? Diopside 88, phosphorite 12, na? So this is the eutectic point nearly this. This is then SiO2 16 is your SiO2 16 and diopside 84. So somehow 84, this is 88. So nearly this. Okay, and your like this one phosphorite SiO2. So the phosphorite SiO2 system, how it looks? It looks like this. This one. Okay, this is the reaction point. This is the N-statite, and this is the eutectic point. Na? This is the N-statite bound N-statite field. This is the N-statite line. This is the reaction point, and this is the eutectic point. So there should be what? Two curves, two eutectic curves or two cotectic curves. One going from the reaction point and another going from the eutectic point. Two cotectic curves, na? So this one comes here and this one comes here. Winter ray phosphorite andesite SiO2 not dioxide. Sorry. डाइऑक्साइड फॉस्फेट सिलिका, ये हो गया तुम्हारा रिएक्शन पॉइंट, ये हो गया इसका यूटेक्टिक. ठीक है, U1 E2 E3. और यहाँ पर है क्या? एनस्टाइट बाउंड्री, जो एनस्टाइट था वो. तो यू कैन प्लॉट दिस लाइक, ये स्ट्रेट लाइन है. ठीक है, E3 एंड इसमें ड्रॉ स्ट्रेट लाइन यहाँ से यहाँ तक. ठीक है, नहीं ओके. सो दिस इज द एंस्टाटाइट. एंस्टाटाइट वाला जो है ये है. ओके, तो हो गया, डायग्राम कंप्लीट हो गया। ठीक है, ये हो गया तुम्हारा टर्नरी डायग्राम। अभी समझते हैं क्या होता है इसमें, क्रिस्टलाइजेशन कैसे होता है। सो ये इम्पोर्टेंट क्यों है? ये इम्पोर्टेंट इसीलिए है, दिस इज इम्पोर्टेंट बिकॉज फ्रॉम ए सिंगल मेल्ट we can find both silica saturated and oversaturated products or silica saturated, you can say silica saturated, just saturated, silica undersaturated and oversaturated, sorry, undersaturated and oversaturated. So this system is important because from a single melt, okay, from a single melt we can find both silica saturated and silica undersaturated products। ठीक है, तो इस सिस्टम के बारे में बेसिक आइडिया हो गया, सिस्टम क्या कैसे है। फॉस्फेट डाइऑक्साइड यूटेक्टिक है, डाइऑक्साइड सिलिका इज यूटेक्टिक, फॉस्फेट सिलिका इज पेरिटेक्टिक। ओके, so only crystallization behavior is there, so you have to study only the crystallization behavior, not the melting or anything, only the crystallization behavior, okay, that is enough। so its melting is also very complicated, so not required actually, okay। so this diagram, okay, in this diagram we can say that dioxide enstatite, okay, dioxide enstatite separates the silica unsaturated and silica saturated products, okay, this field, okay, you can see this field is silica undersaturated, okay, and this field is silica oversaturated or silica saturated, simply silica saturated। ठीक है, ओके। सो अभी इस डायग्राम को हम लोग डिवाइड करते हैं, ठीक है, मतलब उसका फील्ड निकालते हैं, ठीक है, उसका फील्ड निकालते हैं, कौन सा फील्ड में क्या है। तो इसमें टोटल 5 फील्ड्स है, ओके, देयर आर टोटल 5 फील्ड्स और 5 पार्टीशंस। यहाँ पर क्या है, ये है फॉस्फेट प्लस लिक्विड, ये तुम्हारा आ गया यहाँ पे सिलिका प्लस लिक्विड, ठीक है, यहाँ पे एक पार्टीशन आएगा ऐसे करके और ऐसे करके, ठीक है, यहाँ पर एक पीजियोनाइट फील्ड आता है, पीजियोनाइट फील्ड, ठीक है, और ये हो गया डाइऑक्साइड प्लस लिक्विड, कितना हुआ, 1 2 3 4, और ये वाला जो फील्ड है ये छोटा सा, ठीक है, ये छोटा सा फील्ड है, ये हो गया तुम्हारा, नहीं सॉरी 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 सॉरी, ये वाला टोटल हो गया, ये यहाँ पर हो गया एनस्टाटाइट प्लस लिक्विड, ठीक है, ये टोटल फील्ड है, ये वाला वो।
The quadrant to the right hand side, near to the silica, that is silica oversaturated or silica saturated?
This is
Right.
silica, this one is silica saturated, this one, okay।
And, okay. And what about silica oversaturated? Which is the one?
No, that is not like silica oversaturated. You can say this silica plus liquid field is silica oversaturated. Okay, but in case of this diagram, this dioxide and enstatite join divides the silica saturation zone. It is a silica critical zone. Dioxide enstatite line is the silica critical zone. Left of the dioxide and enstatite join, it is silica undersaturated, and right of that silica saturated. Okay, there is nothing oversaturated. You can say this silica plus liquid is the oversaturated zone, okay। if you will take any composition within this triangle, what is dioxide, phosphate and enstatite, ठीक है, any composition, the final product will be a combination of olivine plus pyroxene. Clear? Because dioxide is clino or ortho? Dioxide is clinopyroxene or orthopyroxene?
Clinopyroxene.
Enstatite is
Orthopyroxene.
orthopyroxene. So if you will take any composition in this field, the silica saturated undersaturated field, then the final product will be a composition of olivine plus pyroxene. Can anyone say what will be this rock type? Mafic, not mafic, to give me a particular name. पेरोटाइट्स, ओके, पेरोटाइट्स हो गए, जो लेहरजोलाइट हो गया, हार्जबर्गाइट हो गया, ठीक है, वेबस्टराइट हो गया, वो सब हो सकता है यहाँ पर, पेरोटाइट्स होगा वहां पर, ठीक है. ओके, सो व्हाट विल बी द रॉक ऑफ डाइऑक्साइड फॉस्फेट अनोथाइड सिस्टम? डाइऑक्साइड फॉस्फेट अनोथाइड सिस्टम, इसमें कौन सा रॉक हो सकता है? फॉस्फराइट, डाइऑक्साइड अनोथाइड में कौन सा रॉक हो सकता है इसमें? This is the pigeonite field and this is the diopside field. This is silica, olivine and enstatite field. Okay. So Kanya, anything? Okay. So okay, you can write down the temperature of this reaction point 1557 degrees centigrade. Okay. And you have to write these temperatures also: 1890, 1392, 1713. This is not necessary. You can write this temperature. Writing this temperature is not necessary, but if you will write this temperature, this makes good impression, na? So we'll study the crystallization behavior here. So starting from a composition where phosphite is more, okay, phosphite ज्यादा है, उसके बाद तुम्हारा आ गया क्या, सिलिका डाइऑक्साइड, ठीक है, ऐसे है कंपोजिशन कुछ. तो क्या होता है, तो स्टार्टिंग फ्रॉम द मेल्टिंग, तो ऑलरेडी यू नो दैट हाउ टर्नरी वर्क्स. ओके, सो आई एम नॉट गोइंग टू द वेरी basic details. I am directly starting from the crystallization started. Okay, so above the liquidus it was melt, and when it touches the liquidus, then at point M the crystallization started. The initial composition is also point M. Okay, initial ball composition is also at point M. So at point M the crystallization started. What will be the first crystal? What will be the first crystal? Phosphorite. So phosphorite will be first crystal formed. So phosphorite will continuously be formed, and the melt is continuously depleting in phosphorite and being enriched in SiO2 and dioxide. Okay, SiO2 and dioxide में enrich होता जा रहा है. So now what will happen? This melt will move away from the phosphorite and यहाँ से इस तरफ जाएगा, और किस तरफ जाएगा? सिलिका और डाइऑक्साइड की तरफ जाएगा, क्योंकि मेल्ट में the melt is getting enriched in SiO2 and dioxide. Okay. So when it will touch the reaction point or reaction curve, cotectic reaction cotectic curve. Okay, reaction cotectic curve कौन सा वाला है? ये वाला है, ये वाला reaction cotectic curve. तो when it will touch the Q point, okay, the Q point at reaction cotectic curve, then the phosphorites the phosphorites will start reacting with SiO2 and will produce what? And will produce enstatite. कौन कौन तापस? Okay, so when the melt यहाँ से यहाँ तक continuously from this point to this point continuously phosphorite is being formed. Now at this point what will happen? This is the reaction point. Okay, at this reaction point the phosphorite formed will react with the melt. Okay, will react with the melt and enstatite will be formed. At what point? The question is at what point? Because we have taken a composition where phosphorite is very much high. The composition of phosphorite is very big. Okay, so what will happen? As silica is very less, so this will follow this curve, no doubt. Okay, this will follow this curve and continuously phosphorite is being converted to silica enstatite reacting with the silica. But at some point what will happen? The phosphorite will end. Okay, phosphorite खत्म हो जाएगा. ठीक है, phosphorite खत्म हो जाएगा और सॉरी phosphorite ज्यादा है तो सिलिका खत्म हो जाएगा. ठीक है, SiO2 will continuously react with phosphorite to form enstatite. At some point what will happen? Phosphorite amount is very high. Okay, phosphorite amount is very high because we have taken almost 70% of phosphorite, 70% of phosphorite, 70-80% of phosphorite. So phosphorite amount is very high. So silica percent is very less compared to phosphorite. So for phosphorite, for conversion from phosphorite to silica, let's see, Mg2SiO4 plus SiO2 gives rise to 2 MgSiO3. Correct? 3 2 5 6 4 9 sorry 2 4 2 6 3 2 6 ठीक है. Okay, clear. So for every phosphorite we need a silica. Na 1 mole of phosphorite reacts with 1 mole of silica and gives 2 mole of Mg, 2 of what? Enstatite. Na. So if there is 18 number of silica olivines, okay, and have only 10 to 15 number of silica, then only 15 नहीं 30 हो जाएगा ना. So 30 enstatite will be formed, but remaining 50 phosphorite will remain there. So here crystallization will cease. Okay, यहाँ पर crystallization खत्म हो जाएगा. ठीक है, बाकी जो डाइऑक्साइड है वो यहाँ पर सॉरी आगे. ठीक है, बाकी जो डाइऑक्साइड है और सिलिका है वो यहाँ इस लाइन में जाते हुए ही वहां पर क्रिस्टलाइज कर जाएंगे. ठीक है, सिलिका तो बचा नहीं कुछ. डाइऑक्साइड और ये तुम्हारा फॉस्फराइट वो यूटेक्टिक रिलेशन दिखाते हैं और टेम्परेचर उतना तक पहुंचा भी नहीं है. ठीक है, तो वो क्रिस्टलाइज नहीं करेंगे अभी. वो जब टेम्परेचर आएगा तब क्रिस्टलाइज करेंगे. व्हेन द टेम्परेचर कम्स देन दे विल क्रिस्टलाइज. बट एट दिस पॉइंट silica is exhausted because it continuously reacted with the phosphorite. So silica, so the crystallization will end at this point. There will be the final crystallization will be a composition of phosphorite and enstatite, that is olivine and pyroxene. Clear? किसी को समझ में नहीं आया तो बोलो. When you are taking composition 1, composition 2, composition 3, so that and like that. So when somehow like we'll take another composition between enstatite and your reaction point, that is X. Okay, that is X point. Okay, this vector. Another thing, in case of this first case, okay, first case जब phosphorate ज्यादा था तो वहां पर फाइनल जब क्रिस्टलाइजेशन एंड होगा, यहाँ पे जाके इस लाइन पे एंड होगा, तो ये पॉइंट जिस पॉइंट से एंड हो रहा है वो हम लोग ये बोल रहे हैं कि एस पॉइंट में एंड हुआ है क्रिस्टलाइजेशन. ये बुक में लिखा हुआ है. ठीक है, तो यहाँ पर अगर क्रिस्टलाइजेशन एंड हो रहा है तो ये इसका बल्क टोटल सॉलिड कंपोजिशन क्या होगा? एस होगा. ये बुक में लिखा हुआ है. ठीक है, तो इसका कोई जस्टिफिकेशन नहीं दिया है वो. तो जो भी पढ़ रहे हो बुक पढ़ोगे वो थोड़ा देख लेना कि इसका जस्टिफिकेशन कुछ है नहीं. ठीक है, नाउ इफ विल टेक, यहाँ पर कहाँ पर लेंगे, अगर बाइनरी में हम लोग देख रहे हैं तो ये हो गया रिएक्शन पॉइंट, ये हो गया यूटेक्टिक, और ये हो गया एंस्टाटाइट ना, ये एंस्टाटाइट हो गया। तो हम लोग एंस्टाटाइट और रिएक्शन पॉइंट के बीच में अगर पॉइंट ले रहे हैं, पॉइंट 2, सो दिस इज द एक्स पॉइंट, है दिस इज द एक्स पॉइंट। हम लोग क्या किया, वी हैव टेकन द पॉइंट बिटवीन एंस्टाटाइट एंड रिएक्शन पॉइंट। ओके, so now what will happen, now there is relatively less phosphorite and relatively more silica. Okay, relatively more silica. Now what will happen, this path will go until Q. At Q what will happen, phosphorite will react with silica and produce enstatite. Okay, and this will follow this curve, this will follow this curve. Now what will happen, at some point phosphorite will end, फॉस्फेट क्या होगा, खत्म हो जाएगा। तो जब फॉस्फेट खत्म हो जाएगा तब क्या होगा, तब एक कंपोनेंट खत्म हो गया, नहीं, एक कंपोनेंट जब खत्म हो गया तो ये जो लाइन है, ये लाइन था क्या, यूनिवेरिएंट, ठीक है, ये लाइन यूनिवेरिएंट था, तो ये लाइन से फील्ड तक नहीं जाता, लेकिन फॉस्फेट जब खत्म हो गया तो ये हो गया बाइवेरिएंट। तो बाइवेरिएंट जब होगा, ये क्या होगा, एक कर्व पाथ ऐसे लेगा, कर्व पाथ लेगा दूसरा साइड को, इस साइड को, कौन सा, यूटेक्टिक जो कर्व है, यूटेक्टिक कर्व है, ठीक है, यूटेक्टिक कर्व है, इस साइड को दूसरा साइड को लेगा। क्यों कर्व पाथ लेगा, ऐसे करके क्यों लेगा, ठीक है, उसको थोड़ा समझो, ठीक है, थोड़ा समझो क्यों ऐसे कर्व पाथ लेगा। इतना तक समझ में आ गया कि एक्स में क्या होगा, अरे यार सॉरी, यू अंडरस्टूड टिल नाउ। So you have understood till the point, till this point, that if we will take the composition X, okay, if we will take the composition X, then what will happen? It will follow the same path. It will reach the Q, and at Q, phosphorite will react with SiO2, and it will form enstatite. But at some point, what will happen? As phosphorite is less, so phosphorite will be consumed totally, and after that, the invariant curve, the melt will leave the invariant curve and will go to the other curve, ठीक है, and will go to the other curve through a field, through a curve path, okay, through a curve path. Why this is curve path? अरे यार, why this is curve? Because देखो यहाँ पर क्या हो रहा है, जब इस तरफ तुम जा रहे हो, क्यों जा रहे हो इस तरफ, बिकॉज मेल्ट में कंटिन्यूअसली SiO2 और फॉस्फोराइट घट रहा है, डिक्रीजिंग, नहीं, melt is continuously being depleted from SiO2 and phosphorite, so it was going like this, okay, it was going like this. Now what will happen, it is this is CaMg SiO3, what is dioxide, and this is enstatite MgSiO3 na, enstatite. So the melt is continuously getting, okay, the melt is continuously getting enriched in calcic component, नहीं, ये ऊपर जो डाइऑक्साइड है वो कैल्सिक है, नीचे जो है वो मैग्नीशियम है। तो मेल्ट में क्या हो रहा है, मेल्ट में कंटिन्यूअसली मैग्नीशियम कंपोनेंट डिक्रीज कर रहा है और कैल्सिक कंपोनेंट इंक्रीज कर रहा है, नहीं, सो ये क्या होगा, ये जब ये कर्व लेफ्ट करेगा, ये कर्व में जो जब कर्व से बाहर निकलेगा तो इंस्टाटाइट तो फॉर्म हो रहा है, इंस्टाटाइट तो हो गया फॉर्म, ठीक है, अभी ये क्या हो रहा है, कैल्सिक कंपोनेंट उसमें बढ़ रहा है, तो वो जाएगा टुवर्ड्स कैल्सिक कंपोनेंट, ठीक है, टुवर्ड्स कैल्सिक कंपोनेंट जा रहा है। लेकिन जब इस तरफ ये पहुंच रहा है तब सिलिका भी क्रिस्टलाइज करना शुरू हो गया, ठीक है, तो सिलिका भी सिलिका भी मेल्ट में बढ़ना शुरू हो गया, सिलिका मेल्ट में बढ़ना शुरू हो गया, क्यों, क्योंकि और सिलिका जो है वो फॉस्फेट के साथ रिएक्ट नहीं कर रहा है, फॉस्फेट के साथ रिएक्ट जितना करना था वो कर गया। अभी अगर हम लोग देखेंगे तो सिलिका का परसेंटेज उसमें इंक्रीज होगा, तो ये थोड़ा क्या करेगा, सिलिका के तरफ मूव करेगा, ठीक है, थोड़ा, ज्यादा नहीं, सिलिका की तरफ मूव करेगा, क्योंकि सिलिका का परसेंटेज डिक्रीज हो रहा था, सिलिका का परसेंट डिक्रीज हो जाता जब तक फॉस्फेट फॉर्म हो रहा था। जब फॉस्फेट फॉर्म होना खत्म हो गया तब सिलिका का पोर्शन थोड़ा ज्यादा रह गया, क्योंकि फॉस्फेट एक कंपोनेंट बाहर निकल गया। ठीक है, अब एंसाइट है। समझ आ रहे हो तुम लोग? समझ आ रहा है यार? गेटिंग इट और नॉट? Okay, so now what will happen? Now this crystallization path will follow this path. Okay, follow this path, and continuously silica and dioxide will crystallize. Pyroxene and your silica polymers will get crystallized. Okay, pyroxene and silica polymers will get crystallized, and the crystallization will go this way. But the thing is, irrespective of what, with more phosphorized crystallizing, SiO2 will increase in melt. But with more phosphorized crystallizing, SiO2, yes, obviously phosphorized जब crystallize हो जाएगा SiO2 मिल्ट इंक्रीज करेगा, बट यहाँ पर तो फॉस्फोराइड खत्म हो गया ना, रिएक्ट कर करके SiO2 के साथ। ठीक है, इट इज कंटिन्यूअसली रिएक्टिंग विद SiO2 एंड फॉस्फोराइड इज एग्जॉस्टेड, इट इज कन्वर्टेड टू एंस्टाटाइट ना। हाँ, ऊपर में एंड हो जाएगा, बट द थिंग इज irrespective of any composition, write down this thing. Okay, irrespective of any composition, the crystallization will end in pigeonite field. Okay, pigeonite field, इस pigeonite field में एंड होगा। ये चीज है कि जो भी तुम कंपोजिशन ले लो वो अल्टीमेटली पिजोनाइट फील्ड को पहुंचेगा, मतलब पहुंचेगा, ये है चीज। ठीक है, जो भी दो केस मैंने बताया, तो दो केस में भी पिजोनाइट में जाएगा, डाइऑक्साइड से भी शुरू करो पिजोनाइट में जाएगा, सिलिका से भी शुरू करो पिजोनाइट में जाएगा। ठीक है, तो एवरीथिंग इरेस्पेक्टिव ऑफ एनी कंपोजिशन द क्रिस्टलाइजेशन विल एंड इन द पिजोनाइट फील्ड। ठीक है, इसमें इतना ही था, ज्यादा नहीं था, इतना ही था। तो कुछ समझ में नहीं आया तो बताओ।